Today on How It's Made. Prepared mustard, putting on quite a spread. Violins. We had to pull some strings to show you this one. Nuts and bolts, forging ahead at high speed. And toilet paper. Roll 'em. We eat it on hot dogs and hamburgers, on sausages and sandwiches. No condiment cuts the mustard quite like mustard. The ancient Romans took the mustard seed to what is now France, and by the 9th century, big-time mustard production was underway. Yellow mustard and Dijon mustard have a few ingredients in common, but that's where the similarity ends. Not only are they prepared quite differently, they're derived from different varieties of mustard seed. Yellow mustard is made from the seeds of the white mustard plant. Turmeric and paprika provide the yellow color and sharp flavor. The other ingredients are salt, water, and white vinegar. The powdered ingredients go down a shaft to a mixing tank containing the water and vinegar. Yellow mustard's proportions are roughly 60% water, 20% vinegar, 15% seeds, and 5% salt and spices. The last ingredient to go in is the mustard seed, hull, bran, and all. The tank's rotating mixer blends the ingredients for about an hour at seed-crushing speeds reaching 265 kilometers per hour. The tank's contents empty into several stainless steel mills. Inside each one, a pair of synthetic stones grinds the seeds, a process known as stone milling. That grinding action heats the mixture to about 60 degrees Celsius. The liquid thickens into creamy, bright yellow mustard. Before bottling, they perform what's called a finesse test. This ensures the mustard is smooth enough. If its particles are more than 1/4 millimeter big, the factory adjusts the milling stones closer together to produce a finer grind. They make Dijon mustard from brown mustard seeds, sometimes mixed with other varieties. And they usually use 2 types of vinegar, cider and white. The ingredients ferment in the tank for 12 hours before mixing. That's what gives Dijon mustard its strong flavor. After mixing, it's the same stone milling process we saw before. Here's what the inside of those mills looks like. A rotating stone rubbing seeds against a stationary stone. The same principle as an old-fashioned mortar and pestle. Dijon is made with twice as many seeds as yellow mustard and 20% less water, which is why it comes out thicker and denser and needs the occasional stir. Filters screen out any particles larger than 1/4 millimeter. The factory saves these coarse pieces to put into specialty mustards. Now the creamy smooth Dijon mustard goes into a stainless steel tank. A slow-speed revolving mixer removes the air, which would otherwise turn it brown and dull its flavor. The yellow mustard tanks also have mixers to remove air and to keep the condiment well blended. Both Dijon and yellow mustard have to cool overnight before bottling. From start to finish, it takes about 20 hours to produce yellow mustard, about 32 hours for Dijon, the extra time due to the fermentation period. Yellow mustard has a 15-month shelf life, while Dijon stays fresh for a year. Both should be refrigerated after opening to preserve their flavor. Mustard is a condiment that even health-conscious eaters can enjoy. It packs a lot of flavor in just a few calories. It contains just a small amount of fat, somewhat more if the manufacturer uses oil in the recipe, but it's still a cholesterol-free food. The violin developed in the 1500s, evolving from a series of guitar-like instruments that musicians played with a bow. While the violin is best known for classical music and gypsy music, today you hear it in pop, country, bluegrass, and even jazz. First, they cut a piece of maple, then split it in half to expose the grain in mirror image. They melt down glue flakes made from animal hide, then bond the pieces together. Violin makers use only glue, never nails or screws. These pieces of wood will form the back of the violin. After 4 hours, the glue is dry and they can remove the clamps. Using a small plane, they even out the surface. Then they trace the violin's shape and cut it out. They shave the surface, sculpting a downward slope from the middle, using an even smaller plane. Then they carve a groove along the circumference. After dabbing it with glue, they insert what's known as purfling, a reinforcement made from a thin strip of hardwood, usually maple. Finally, they carve the reverse side to the right form and thickness. Next, they make the sides of the violin, known as the ribs. First, they soak thin strips of maple or sycamore and press them against a heated bending iron to curve them. Then they glue the strips around a form, connecting them at the top and bottom and at the corners with small blocks of wood. They clamp everything together and let the glue dry for 4 hours. Next, they glue thin strips of wood, called counter ribs, onto the edge of the ribs. This enlarges the surface so that it's easier to glue the ribs in the back together. They make the violin's front, or belly, from a solid piece of spruce. To the underside, they glue a spruce support bar called the bass bar. Sound escapes through the 2 curved slots called F-holes. They cut out and carve the violin's neck and scrolled head from a piece of maple. Then they glue it to the body. They sculpt the fingerboard from ebony, a hard wood that's durable enough to withstand centuries of violinists' fingering. Using a tool called a peg hole reamer, they make holes for the ebony or rosewood pegs around which the strings are wound. They coat the wood with 4 or 5 coats of varnish, depending on the color, then polish it with several coats of oil over several days until the finish is shiny and silky smooth. Next, they insert the sound post. This little pine cylinder conducts sound and supports the belly against bowing pressure, so it's critical to position it in precisely the right spot between the belly and the back. It's not glued, but rather wedged into place. The bridge isn't glued either. It's held in place by the pressure of the 4 strings, which they feed through the ebony tailpiece and wind onto the pegs. The bridge has little notches in which the strings sit. The violin is finished. They make the bow from horsehair and a high-quality Brazilian wood called Pernambuco. They bind the hairs at one end with a strong sewing thread, then burn them and seal them with wax to prevent fraying. This end goes into the frog, the wooden box at the bottom or heel of the bow. They cover the frog with a mother-of-pearl lining, then slip on a ring made of nickel, silver, or gold to prevent the hairs from tangling. Next comes the screw that controls the tension of the hairs. They comb the hairs to make them parallel. then insert them into the tip of the bow, known as the head. They tighten the screw until the hairs are taut. Finally, they rub on rosin, a sticky pine tree resin that keeps the bow from slipping off the strings. At How It's Made, we pride ourselves in showing you the nuts and bolts of how everyday items are made. So it's about time we visited a real nuts and bolts operation. We sure couldn't do without these tiny but essential pieces of hardware. If only they weren't so darn easy to lose. Nuts and bolts are made from what's called steel wire rod. After spending up to 30 hours in a furnace to soften it enough to be worked, the wire rod goes into a bath of sulfuric acid to remove any rust particles. It's rinsed in water, then coated with phosphate, a chemical compound. This prevents the steel from rusting before the bolt forming begins, and lubricates the steel to make forming easier. They form the bolts by cold forging, shaping the steel at room temperature by forcing it through various dies at high pressure. The forming machine first straightens the wire rod, then cuts it into pieces slightly longer than the bolt length. The extra will become the bolt head. Each piece goes through a die that makes it perfectly round, then through a series of dies that progressively shape the head of the bolt on one end. The machine heads up to 300 bolts per minute. Here's what the heading stages look like in slow motion. This die creates a slight collar. The next one turns it into a round head. Then the last die transforms that into a hexagonal head, the most common shape. Next, the machine forms the opposite end of the bolt. A tool called the pointer shapes the bottom of each bolt, creating what's called the chamfer, the part the nut catches onto. Here's the bolt before and after the chamfer. The bolt needs threads to enable the nut to screw onto it. Once again, they use the cold forging method. High-pressure rollers press in the thread pattern, as we see here in slow motion. This is the actual speed, up to 300 bolts per minute. During each production run, they take several samples to verify dimensions. They use various measuring devices, a micrometer to check the bolt's length, calipers to measure the width of the head, and a ring gauge to check the threads. To make the nuts, they use a process called hot forging. They cut steel bars into small pieces known as slugs, then heat them to 1200 degrees Celsius to make them malleable. As we see here in slow motion, hydraulic hammers punch the slugs into hexagons, while a die pierces the hole. Then a tool called a tapper drives into the hole to cut the threads. That black liquid is a lubricant oil to minimize the wear and tear on the tappers. The nuts and bolts now go into an oven at 870 degrees Celsius for about an hour. This gives them the required strength. Then a rapid cooling in oil for 5 minutes solidifies the steel's internal structure. By now, the steel is hard but brittle, so they heat the nuts and bolts for another hour. This removes their brittleness, yet maintains their strength. The quality control team pulls samples off the line, measuring how much force it takes to break them. If a bolt meets its minimum strength requirement, it passes inspection, provided the break occurred in the threading, the weakest part. Finally, packaging, labeled among other things by size and grade. Toilet paper is probably the most indispensable item in your home. After all, it's not something you want to run out of at the wrong time. Most of us probably take our rolls of toilet paper for granted, so you may be surprised to learn that bathroom tissue, as it's properly called, is a relatively new invention. The Vikings used wool, the ancient Romans employed sponges, and French royalty wiped with lace. Then in 1857, an American entrepreneur figured that people had had enough of using leaves and corn cobs and newspapers and mail order catalogs. So he invented therapeutic paper, as he so tastefully named it. Toilet paper came only in piles of pre-cut sheets until 1890. That's when one company introduced bathroom tissue on a roll. Ever wonder where all that recycled paper goes? Well, look no further than your own bathroom. Many brands of toilet paper begin as recycled paper. The bales of paper drop down into the pulper, a giant tank with an agitator similar to what you see in a washing machine. It mixes the paper in lukewarm water for about 10 minutes, transforming it into what's known as pulp and screening out all the bits of metal and plastic. Now they have to take out the ink. The ink removal system injects the pulp with air. The ink particles attach to the air bubbles, which rise to the top. The system then skims off the foam, leaving the pulp ink-free. Next, the pulp passes through a series of rollers which squeeze out the water. This dries out the soggy pulp, enabling it to absorb the chemicals they'll use to bleach it. Revolving knives now chop it up again to prepare it for the bleaching process, the details of which are a closely guarded trade secret. The bleach turns the gray pulp a pure white. The company says it does this without using chlorine or other toxic chemicals. They spread the wet pulp onto a flat screen that runs through a hot dryer. In less than a second, the pulp dries into a delicate paper a mere 1/10 of a millimeter thick. Each spool holds 75 kilometers of paper. That spool now feeds a machine with rollers that emboss a pattern, in this case, a waffle print. The pattern isn't just aesthetic, it also makes the paper thicker and therefore more absorbent. Elsewhere in the factory, production is rolling, so to speak, with 2 strips of cardboard, each 8 centimeters wide. The machine coats the underside of the top strip with glue, then winds the 2 strips diagonally together to create a continuous cardboard tube. The machine then cuts the tube into 165 centimeter lengths. The tubes ride an elevator to the toilet paper zone. There, 2 giant spools of paper feed what's called the winding machine. The 2 sheets come together to form a 2-ply toilet paper. The paper then winds onto a cardboard tube, creating a super wide roll of toilet paper. When the roll is full, a blade automatically cuts the paper and winding resumes on the next tube. The machine automatically seals the end of the roll with glue to prevent unraveling. A circular saw slices the super-wide toilet paper roll into 16 standard rolls, each 10.2 centimeters wide. The toilet paper is finished and ready for packaging. This batch is for commercial use. Each roll is individually wrapped in paper. Check out this slow-motion wrapping action. Toilet paper destined for residential use gets wrapped in transparent plastic, 4 to 30 rolls per package. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.